All right, today we're talking about learning target 6 for radicals and rational exponents. So we're switching where we're going to be solving equations instead of simplifying expressions. So we're looking for x equals 2, x equals 5, and answer. The vocabulary: square root equation, radical equation, and extraneous solution. Well, square root equation is kind of like it sounds. It's a square root problem that's an equation, and you'll solve it. Radical equation, well, it could be a cube root, a fourth root, a fifth root, but you're still looking to solve an equation. And then there's that extraneous solution that we've seen several times. Do you remember what that means? Extraneous solution. What does that mean? Ian, what does that mean to you? Exactly. It's a solution that doesn't work. So when you're working these problems, there'll be a possibility of getting answers that just don't work, which means you have to check your answers. Okay? That's all that means. All right, now there's a step-by-step process here for solving every problem today. Number one, isolate the radical expression. Just like when we were solving an absolute value problem. For example, if we were solving 2 absolute value of x plus 1 minus 5 equals 7, what would your first 2 steps be? Add the 5 and then divide by 2. Isolate the absolute values, right? Same thing here, it's just that absolute value of x plus 1 will be a radical. Okay? Then step 2, if it's a square root, square both sides. If it's a cube root, cube both sides, and so forth. And we'll look at 2a when the problem comes up, because it's kind of a special situation. It'll come up on example 4 and 5. But after you've squared both sides or cubed both sides, solve the equation that remains. You'll either have a linear, a quadratic, or an absolute value equation. 3 things that we've studied before, right? Old stuff. And then finally, check your answers to make sure they're not extraneous. So let's dive in. Example 1. Step 1, isolate the absolute value, which would mean what? Subtract the 3. So we get the square root of 2x minus 3 equals 5. Step 2, now that they're isolated, the radical is isolated, it's a square root, so square both sides. Square both sides. On the right side, we get 25. What happens when you square a square root? It kind of gets rid of the square root, doesn't it? So you're going to be left with what on the left side of this equation? The 2x minus 3, the radicand. 2x minus 3. Which means we are left with a linear equation to solve. Add 3, divide by 2. Add 3, divide by 2. 2x equals 28, divide by 2, x equals 14. You do need to check the answer, so we can check it in our head. Let's do that in our head. In the absolute value, what's 2 times 14? You can do this. 28, yep. And then subtract 3, 25. So that 25 is under a square root, which means the square root of 25 is 5. So what is 3 plus that 5? It gives you the 8 that it was supposed to. So you can check it in your head, check it with your calculator, or sometimes you just may have to write it down on paper, but you do need to check it. All right, moving on. Example 2 is a parentheses 4x plus 1 to the 1/2. Well, we know, what does that 1/2 really represent? Square root. So it's basically the same problem as the one in number 1. It's just written differently, right? So I'm going to leave it written the way it is, but treat it like a square root. First step, isolate the square root that you're visualizing by adding 5. So we get the absolute, or we get parentheses. I don't know why I want to keep saying absolute value. Parentheses 4x plus 1 to the 1/2 equals 5. In our mind, that's a square root. It's isolated. So we square both sides. This will further prove that when you square, you just end up with the radicand on the left side. But first, the right side. 5 squared, 25. What happens when you have a power to a power? What's the rule? Power to a power. You multiply the powers, right? So what's a half times 2? 1, which means you have 4x plus 1 to the 1 power. It kind of canceled out the radical, right? So you end up with 4x plus 1. And you have the option of writing this problem as a square root and doing it exactly like we did number 1 if you wanted to. Okay? All right, so then we got a linear problem. Subtract 1, divide by 4, and our answer is maybe 6. Let's see if it works. What is 4 times 6? 24, yep, plus 1, 25. And then that 1/2 is basically square root of 25. Does 5 minus 5 give you 0? Then we're good. It works. All right. Any questions so far? All right, it gets weird on the next 2 problems. We have a review problem before we get to those, though. So try this review question. Yeah, there's hints to the right. But try the review problem. X squared minus 5 equals 11. It's on the bottom of your notes. What's your first step? To what? Add the 5, yeah. So x squared equals 16. That's like isolating the square root, right? You know. Now, we would have squared if it was a square root. What did we do when it was a x squared? We took the square root of both sides, right? And we wrote x equals definitely 4. But did you remember what also we did? What we also put there? We thought that what could you square and get 16? A 4 or a negative 4, right? So when you take the square root of both sides, you have to put a plus or minus there, right? All right, now I'm not going to go into a lot of explanation on this next part, but the reason I reminded you of that is because sometimes when you're solving an equation and you take the square root, or you square stuff, or you do stuff, you have to consider the possibility that you've changed the problem. All right? So in number 3, there's a rule on the front page that tells us what to do. What is the solution of x to the 2/3 equals 16? Well, if we look back at the first page, it tells us if it's a rational exponent in the form of m over n, x to the m over n equals k, then raise each side to the power of n over m, the reciprocal of the fraction. And then furthermore, it goes on to explain if either m or n is even, then you'll have to use absolute value signs. All right, so let's do this problem, follow the rule, and then talk about it. Example 3. The rule says x to the 2/3. If we have x to the 2/3, we should raise it to the what power? Raise it to the 3/2 power. And what you do to one side of an equation, you have to do to the other. So 16 also gets raised to the 3/2 power. All right, on the left side, we get x to the, what's 2/3 times 3/2? What's 2/3 times 3/2? Be 2 times 3, 6 in the top. 3 times 2, 6 in the bottom. So 6 over 6, it's 1. It gets rid of the exponent. So x equals, now use your calculator here. Type in 16 to the 3/2, or think of it as the square root of 16 cubed. So it's 4 times 4 times 4. Either way, you get 64, right? Now, the rule said if you raise both sides to m over n, and either m or n is even, you need to use absolute values. We raised it to the 3 over 2. Are either of those even? Then we need absolute values. So our absolute values go around the x, which is now case 1, case 2. Case 1, the x could be 64. Case 2, the x could be negative 64. So you're going to see me writing that as plus or minus 64 from now on, which is your case 1, case 2. Case 1, case 2. So you have 2 potential answers, 64 and negative 64. All right, so let's see if we can do this. Pull up the Yeah, we're not going to be able to do that there. Or is it pulling? Nope, it's not pulling it up. All right, we'll just have to do that off camera. All right. We're going to take our calculator and plug in 64 and negative 64 just to see if they work. All right. So grab your calculator. And we're going to type in 64 exponent parentheses 2/3 and see if it works. 64 to the 2/3. When you hit enter, you're hoping to see 16. And we do. Now when we check the negative 64, make sure you put parentheses around the negative 64. So parentheses negative 64, exponent 2/3. Make sure you have parentheses around your negative 64. And hit enter. Do you see 16 on that as well? Okay, so what that means is both numbers work. The 64 works and the negative 64 works. And if we hadn't put absolute values around that answer, look back on the board here. If we had not put absolute values there, we would have just said x equals 64. We'd have found that number, 64. But would we have found the negative 64? No, we wouldn't have found it, which means we would have missed one of the answers. So there's another reason that we have to put the absolute values there. All right, moving along. Number 4. 3 times x plus 1 to the 2/3 equals 12. Step 1, isolate. So divide by 3. You got it. Divide by 3. We get x plus 1 to the 2/3 equals 4. Now that they are isolated, we're going to do what? Follow the rule on the front page. Raise it to the power of, it's 2/3 now, so flip it 3/2. Raise this left side to the power of 3/2 and raise the right side to the power of 3/2. Is either of those numbers, 3 or 2, even? Yes. So we'll need absolute values. Let's do the easy side first, the one that the calculator will do for us, basically. That's the square root of 4 cubed. So that's the square root of 4 times the square root of 4 times the square root of 4. It's 8. Yeah. And the calculator will agree with that. It's 8. On the left side, we get x plus 1 because the 2/3 power raised to the 3/2 power becomes 1. But we said one of those two numbers is even, so we need absolute values. The whole radicand, the whole base, x plus 1, needs the absolute values. So you put your absolute values around the x plus 1. And this just turned into what kind of question? An absolute value, case 1, case 2. So the way I'm going to work them from now on to save room on paper, I'm not going to do 2 separate columns. I'm just going to say x plus 1 could be 8 or negative 8. That's what we always do, right? Case 1, x plus 1 is 8. Case 2, x plus 1 is negative 8. So you're going to see it in my homework keys like this. X plus 1 equals plus or minus 8. Case 1, case 2. And then I'm going to subtract the 1 to solve for x and get final answers of negative 1 plus or minus 8. So one at a time, what are the two potential answers? Negative 1 plus 8, 7. Negative 1 minus 8, negative 9. All right, and we're going to do this off camera because we couldn't get the calculator to pull up again. But we're going to check them. We're going to do a little bit in our head, just a little bit. First, let's check the 7. If we plug a 7 in for x, you have a 7 plus 1. You can do that in your head, right? 8. So what I want you to type in the calculator is 3 parentheses 8, and then put an exponent of 2/3 on that 8. When you hit enter, what are you hoping to see? 12. Mine says 12. Yours says 12? Okay. So that means to us that the 7 works. Now let's check the negative 9. We can do this first part in our head. What's negative 9 plus 1? Negative 8. So type in 3 times parentheses negative 8. And then put your exponent 2/3. When you hit enter, do you see 12 again? Mine says 12. Does yours not say 12? Okay, well, change views for just a second. All right. Check how you typed it in. 3 parentheses. Your base was 8 in the first time when we plugged in a 7. Your parentheses for your base was -8. So use parentheses, and you'll get 12 on both. Okay? All right. So back to the computer screen. So they both work, which means we have 2 answers. Questions so far? We only have 2 more to go. All right, last 2. Example 5. What's the solution of 3 times the 5th root of x plus 1 cubed plus 1 equals 25? What's your first 2 steps? Subtract 1 and divide by 3. Isolate the radical. Subtract 1. 3 5th roots of parentheses x plus 1 cubed equals 24. Divide by 3, and you get the 5th root of parentheses x plus 1 cubed equals 8. And then you have 2 options to finish this problem. We need to talk about them before we do one. You could raise both sides to the 5th power. So let's talk about what would happen if you did. On the left side, if you raised it to the 5th power, what would come out of the radical? An x plus 1 to the 3rd power. Agree? Which means you'd have to cube an x plus 1, which means you're going to get a polynomial with an x cubed. Okay. On the right side, you just get a number, right? So then we'd be solving a polynomial. Now, the other option that we have is to do what we've been doing in the last 2 problems, and that is change this from radical form to exponential form. If we change that to exponential form, it would say x plus 1 to the what power? What would it say on the left side if we change that to x plus 1 as your base? The exponent would be something over 5, because the index is 5. Be 3 over 5, wouldn't it? And if we wrote it this way, we could raise it to the 5th thirds and get rid of all those exponents. That will be less work because we won't have a polynomial to solve. We'll just have an absolute value or a linear to solve. So that's the route we're going to go. Rewrite it in exponential form and then raise both sides to the 5 thirds. Is either 5 or 3 even? No, so we don't need absolute values this time. On the left side of the equation, we get x plus 1. On the right side, it's the cube root of 8 to the 5th. So it's the cube root of 8 times 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 the cube root of 8. Exactly. Good. 32. 2 times 2 times 2 times 2 times 2. Or let your calculator do it, and it will say 32. Subtract 1, x equals 31. And for the sake of time and in the video, we're just going to trust that it works. 31 does work when you plug it back in. The final example, example 6, has an extraneous solution. So when we do this next one and the last one, this is it, number 6, the final question. It will have an extraneous solution. So let's see what happens here. First step, what would you do? You're right, add the 5. Get the radical by itself, so add the 5. You can see that we got an issue now. We've got a square root of x plus 7 on the left, and we have a binomial on the right, x plus 5. We still follow our steps to get this x out of the square root by squaring both sides. We still square both sides. But when you do, the left side of the equation becomes x plus 7. But the right side, you have to be careful because most of us, not most of us, but over half of us missed this question on the last couple of quizzes. When you square a binomial, it's not x squared plus 25. You have to FOIL it. You square a binomial, you have to do x plus 5 times x plus 5. So when you square those x plus 5 times x plus 5, you get x squared plus 10x plus 25. Now, we have 2 options to solve this quadratic. get x squared by itself, or make the whole quadratic equal 0? Can we get x squared by itself without the x getting in the way? No, we can't. So we got to go with the 0 option. So that means move everything to one side. Subtract your x, subtract your 7. So we get 0 equals x squared. What happens when you subtract that x? Yes, 9x. And when you subtract the 7? 18. Most of the problems in the homework are nice ones like this. In other words, that quadratic will factor. What will multiply to make 18, but add to give 9? That would be 3 and 6. So what are the two potential answers? What would make x plus 3 0? Negative 3. What would make x plus 6 0? Negative 6. So those are the two potential answers. And I've already told you one of them doesn't work. So your task to finish off the notes is to take your calculator or just your brain, figure out which of these two doesn't work, and then tell me why. So I'll give you a second to think that through, and this will finish our notes. Is it negative 3 or negative 6 that doesn't work? You finding it? Mm-hmm. All right, which one are you thinking does not work? Negative 6. All right, well then let's check that one on the board. Negative 6 plus 7 is 1. And on the right side, you'd have to put the negative 6 there as well. Okay. What's the square root of 1? 1. So 1 minus 5, does that equal negative 6? Negative 4 does not equal negative 6. So you're right. Those are not equal to signs, which means that we go down here, cross out that answer. It doesn't work. We only have one answer, and it's negative 3. You did check that one, by the way, didn't you? And it does work? Okay, good. All right, that's learning target 6.